Welcome to the overview of Wi-Fi use case 6, focusing on SDN Traffic Engineering capabilities. And this is the result of collaboration from Thales Communications and Security Group, I2CAT in Barcelona, and HENet, the Irish Research and Education Network provider. Developers and infrastructure owners and operators will be interested in this integration solution of various SDN type software components, which utilize dynamic network provisioning across the GEONT networking infrastructure to provide an alternative to having to use a congested Wi-Fi network connectivity link. The major innovation points that have been illustrated in this showcase are tools such as OpenNAS, a network connectivity provisioning solution which has been integrated with an SDN monitoring module to set up inter-node connectivity using non-Wi-Fi node connectivity services. This allows the GEONT bandwidth and demand service to be integrated with SDN technology to match the changing needs of Wi-Fi end users. Guaranteed network connectivity and bandwidth is vital to deploy advanced applications in a federation of cloud services. The future internet developer doesn't have to take care of dimensioning his network capacity for long-term usage. The infrastructure owner only has to set up what is really needed when it is needed, so it is almost an on-demand service. The SDN monitoring module checks the network itself and calls the OpenNAS platform to orchestrate the SDN-based connectivity service. While the infrastructure owner must control the inter-data center bandwidth used by his users, the dynamic bandwidth application gives the capability to provide more network resources if required due to peak demands. Benefits which arise for both infrastructure owners and developers are that infrastructure owners can offer a more efficient inter-data center resource sharing and management service that may allow them to provide services to a larger number of users. To provide a federation of cloud services to look as if it were only one data center by providing network connectivity between virtual machines across remote data centers and with guaranteed bandwidth. Future internet developers can now also develop applications that have specific needs in terms of bandwidth, even in a federated cloud environment. They initially subscribe to a certain amount of bandwidth and let the infrastructure owner monitor and upgrade it if the application really requires it. The showcase shows the benefit of interconnecting, monitoring, controlling, and adapting network resources dedicated to each tenant in an SDN environment. Using the Wi-Fi portal, an end user deploys his infrastructure VMs across Wi-Fi nodes distributed in different locations. If you want to deploy such a service with VMs in these inter-federated Wi-Fi nodes, you may have to have guaranteed bandwidth between the Wi-Fi nodes. But the developer can't be sure what bandwidth he needs to deploy the services, and he's probably unaware of other quality of service parameters such as latency for his network or for the inter-Wi-Fi node connection. So initially the developer will at best guess the bandwidth that he needs for the application. In the background, the TCS monitoring component checks the network into data center traffic in real time and sends an alarm to the user using the monitoring dashboard if his inter-data center traffic has crossed the threshold he has allocated. When the user needs grow more, the initial bandwidth becomes not sufficient. The network is congested and the quality of service is now degraded. So the user now starts to find that these applications start to run with problems. Normally, the user would have to start to negotiate for more resources. However, with the solution being showcased, the network monitoring component detects congestion across the network link in real time, triggers OpenNAS to react by configuring an alternative high-capacity guaranteed bandwidth and demand path for the application. Once the new inter-data center connection is established, it gives enough bandwidth to the application so the quality of service now appears restored to the user. So network congestion is not causing a problem anymore. The user did not know how to request additional resources, or he didn't need to know the concepts of how to provision the network to get such resources. In this showcase, we show the benefits of integrating Wi-Fi network services with tools to monitor network activity and provision other network resources when reacting to quality of service degradation in a multi-cloud federated environment, where the capability of the SDN network controller to monitor each tenant network is shown that it can react to maintain the network quality of service for all Wi-Fi users. Bandwidth and demand can be coordinated by the Open NAS service when invoked by the SDN monitoring component to create an alternative guaranteed bandwidth circuit to alleviate network congestions in the current Wi-Fi network. This allows the use of VMs dispatched in different Wi-Fi nodes in a transparent manner. That is, it looks as if they're all in the same data center. Developers and infrastructure owners are now freed from having to eventually react to provide extra connectivity resources as applications grow. Thank you.